Hello everyone, Phantom Coders back here with another tutorial. Now this one is something that I have discovered very recently when making a scrolling platformer game. No, a scrolling 2D game. So, I know you've all seen this kind of code where you use this script to make enemies chase you in in any scroll game. But you can clearly see that the enemy doesn't move according to direction. Instead, it looks like a weird, janky mess that. See, look at that. It doesn't move. It moves in a way that is uncanny, and also the script here is incredibly long and it's kind of disorienting. But I have found a solution to make the moving much more smooth and also to make it move by direction. Basically, this script is just using this change x by 10 or change y by something. It's using these kinds if you but the new script that I'm proposing uses this script, move 10 steps, and this one relies on direction while these two do not. And I'm going to be doing the same over here. So what we have to do, and really it only needs two lines, we just remove it all and start over. I'm going to change my XA. I just name it XA. You can change name it to X or whatever you want. We are going to change our XA by the sign of our direction, and we're going to multiply this by our speed. Then for the Y, or what I named YA, we are going to change this to cos of our direction, and then we multiply it by the speed. Now let's see the difference. Would you look at that? Doesn't that look smooth? Now instead of just snapping to the player's position, it now moves in the direction that it's facing. And it just uses two lines of code. And it also has the same glitch that often happens when you're using a move, so that basically just proves it. Now, for an if you don't know what this does, let me explain it to you. Let's say that this is our direction. This is our circle, or it stands for the direction. As you can see here, if I tap in the direction, it shows this circle with this arrow pointing towards, you know, pointing towards the direction we are facing. Now, over here in the circle, I will draw a vertical line from 0 degrees to 180 degrees and another line, but this time horizontally, from 90 degrees to negative 90. Now, the way sine works, I'm going to explain it in a very simple way, not not very overcomplicated. It measures the distance between your direction and the vertical line. And it's kind of simple in this way. So let's say my direction is going to be 0 degrees. So the distance between my direction and the vertical line is obviously going to be 0 because sine 0 degrees is equal to 0. But if I were to place it on 90 degrees, then the distance between the vertical line and my direction, which is 90 degrees, or we can say 90 degrees, would be 1. Now let's look at it over here. Sine 0 is 0 and sine 90 is 1. This is basically the distance between your direction and the vertical line. It's that simple. But you'll notice that we use this for the x but not the y. For the y, we're using the cos or the cosine. Now the cosine works in a very similar way, But instead of it being the vertical line, we're measuring the distance from our direction to the horizontal line. So basically, if you were to put your direction at 90 degrees or cos 90 degrees, it would just equal to 0. But if you were to put it at 0, then the distance, or 0 degrees, then the distance between our direction and 90 degrees is cos 0 is 1. And that's what happens in this code. Basically, the old code that I used, it just changed the x and y depending on the position of the player. So let's say if the player was over here, it would just change the x and y until it reached the location of the player, like that. But what my new code does, or what this code does, it moves towards the player using direction. It's not the janky thing that moves like this. Instead, it actually regulates the x and y to move in a smooth way pointing towards the player. And you'll see here that I multiplied it by speed because, as we all know, if you multiply something by 1, you get the same. So if I multiplied my speed by this sign of direction, it would it would modify the x value or the x speed to be on par with the direction it's facing. So that's how this code can easily make for a smooth moving enemy in a 2D scroller or a top-down shooter game. This is actually gonna be, it's going to be really simple to do this. You don't really need to understand it. You can just copy this code and then there, it's all done. But then you might be saying, "Oh, but I don't want it to move like I want it to be like this thing. You know, this thing. I just wanted to I don't want it to look like this. I want it to look like this." Well, we have set rotation style. You can just set it to don't rotate. So while it's pointing towards sprite 1 and then moving this, you could basically, there, same smooth movement with none of that direction. It's that simple. Let me just, and they all face together. So yeah, that's it for this tutorial. Here's the full code if you want to copy. And also here, this is basically just for the player, and this is for the enemy. So that's it, and I hope you learned something new, especially with this whole sign and cost thing, and I'll see you in the next tutorial. Bye bye.